Okay, check 1 2, check 1 2, testing, testing. Should have a decent stream for everyone tonight. It should be a pretty quick one. I know it's kind of late, and it's also St. Patrick's Day. So happy St. Patrick's Day. I should have worn green. Green is my favorite color. I wear it all the time, and it's like the one day I don't wear green. But that's all right. Show goes on. So I wanted to discuss a lecture that Sara Walker did at Mindfest, this episode of Theory of Every0ne Live, and it was recorded and uploaded by Curt Jaimungal, and it is on the Theories of Everything YouTube channel. The link to the full lecture is below if you want to watch the full lecture, which I always recommend watching the full lecture or stream that we are discussing at the link that is always included in the description below. Subscribe to the people that we talk about, or the people who upload the streams that we talk about, I guess, at least. They usually have great content. So with that, Sara Walker is somebody that I've discussed on here a couple times at least, but it's been a while. And Sara is a researcher at ASU, which is Arizona State University. It is in Phoenix, Arizona, which is close to where I'm from. I'm from Tucson, Arizona. So this is, great to hear that my local universities are doing such great work, I will say. But let's get into the lecture. So it is on assembly time or combinatorial time within assembly theory. And we're going to talk more about assembly theory and how it is similar to and different from sentient singularity theory, which is my own piece of work, observer theory, which is Stephen Wolfram's piece of work, and then constructor theory, which is Chiara Marletto and David Deutsch, I believe. So there's a lot of overlap between these, I guess, theories, if you could call them that. But there's also, some key differences, I think. But this one is the one that I wanted to talk about. This is the stream right here. And let me know in the comments if you hear me well, and hit the like button. It really helps fuel the algorithm, please. But this is the stream that we're going to be discussing, Hidden in Plain Sight. Earth Holds the Key to Alien Life with Sara Walker. And this is her intro.
Where is all that information? Please tell me. We want to go out to space to look for life. What we should be doing is looking here on Earth in chemical space. Because where aliens exist is in the possibility space of things that our universe can construct, and we can do experiments on this planet.
Schneider, who is the director of the Center for the Future Mind. Sara Walker is a professor at Arizona State University of astrobiology, and here she talks about the hard problem of consciousness, the hard problem of life, the hard problem of matter, alien life, and of course, assembly theory. Stuart Hameroff is coming on next, and all of the talks from the AI and Consciousness Conference, also known as Mindfest, are in the description, as well as the link to the website to the Center for the Future Mind is in the description. I recommend you check it out. You should also know that right now there's a 2-hour video on the mathematics of string theory, which was just published. It's string theory like you've never heard it talked about before. The link to that is also in the description. For those of you who are unfamiliar with this channel, welcome. My name is Curt Jaimungal, and this is Theories of Everything, where we delve into the topics of mathematics, consciousness, physics, and artificial intelligence with depth and rigor that's distinct to this channel, due to us not eschewing technicality in favor of a wider market. If this fastidiousness is interesting to you, then you're in safe hands here at Theories of Everything. All right, now enjoy this presentation by Professor Sara Walker.
Guess we can get started. For our second speaker at Mindfest, we have Sara Walker. Sara's a theoretical physicist and astrobiologist at ASU, Arizona State University. She's the deputy director of the Beyond Center, an external faculty at Santa Fe Institute as well, and a couple other centers out there. Her main focus is original life research, constructor theory, and looking for assembly theory. Assembly theory.
Which I love, but it's not my theory.
My mistake. And looking at see if we can find signatures for life on other worlds, technosignatures, which is really interesting. Thanks for coming, Sarah, and turn it over to you.
Great.
Okay, so by the way, Curt Jaimungal did an iceberg to string theory. Is I think the title of the video. It is just a huge overview of string theory and the current state of physics, and it's very, very rigorous, and I highly recommend watching it. It's definitely something I've watched it, and it's definitely something that I'm gonna end up having to watch multiple times. And it's one of those videos where you can reference it again and again, and you'll learn something new every time. So it's quite a piece of work. I highly recommend watching that, as he said in the video. But this intro to Sara Walker just basically described, where she works and things like that, and what she looks for. She's very focused on quote unquote origin of life research, as was stated. Her and Lee Cronin, who is another, I guess I think he's technically a chemist, but at this point where we're at, there isn't much of a difference between all of these things. Curt even gave a talk, I think, at one of these panels, and it was like Where the Polymaths, I think it's called. I recommend watching that one as well. And he talks about how just like the difficulty with moving science forward is that we need people who are accepted and also well versed in discussing multiple fields, I guess, topics across multiple fields. And that is really what you see a lot with the current discussions in physics, whether it is intentional or not. It is an inevitable path that we go down, where just structure in general is the focus. And we'll see that tonight because Sara Walker's work and Lee Cronin's work is very much like that. So here, this is a first clip on the origin of life problem, I guess.
I work primarily on origins of life, actually not origins of mind, but as I heard earlier this morning, those problems are probably deeply related, and I am interested in both. I just think the origin of life is so tractable and solvable within the next few decades that I really want to make it happen. My training is in theoretical physics, as a theoretical physicist, and I'm really interested in fundamental laws. And so a lot of people that have approached the origin of life in the past have tried to do it from the perspective that known laws will be sufficient to explain the origins of life. That is not my take on the problem. My take on the problem is we're missing something fundamental, and that there are new theories to learn about how reality works when we're studying things like life and mind. So I went through like the whole formal education in physics, but when I actually really started working on this problem, I realized that there was not a particular shoe that fit this problem. And so I've been spending most of my career trying to think about what would be the structure of laws of physics that would explain life. So that's just to give you a little bit of framing for how I think about the problem. And what I want to talk about today is this theory that I've been working on with my collaborator, Lee Cronin, and a bunch of grad students and postdocs and other collaborators at Santa Fe Institute, called assembly theory, which is an attempt to explain life from a perspective of a more fundamental understanding. And it has some really interesting philosophical properties of the theory that I'm hoping to touch on today, which I think will frame some interesting questions on the nature of what minds are as products of evolution, and the fact that things that are complex are only structured by an evolutionary process and an informational process. And we need to take that as part of the fundamental physics. So when I approach the questions of minds, the thing that I think is most interesting as a physicist is not what a thing is, but what does it do? And what I mean by that is, does it have any causation in the universe? Are there measurable consequences for a thing existing? And so I've been thinking about the question of consciousness and minds for a while now, but the kind of question I really focus on is not the one of subjective experience, but if there are some things that exist only because minds exist, and they would be a measurable consequence of a mind existing.
So what's interesting about this is that it seems like assembly theory is looking more to, I guess, map the products of mind, the impacts or the effects of minds, instead of actually mapping minds. I'm not, this is, it's a little bit messy, because I think that there are some things that assembly theory has not yet nailed down that are kind of critical to understanding how to contextualize all of this. But I think that it's got, a lot of I guess just it's got a lot of potential. I will say that it's kind of similar to constructor theory, but I think that it seems like it's a little bit more well defined. But that is, from an outside perspective looking in, and or it's a little bit more comprehensive, I guess you could say. But in this talk, this is part of the problem with this entire subject, which we don't even know what that subject is. I guess it would be what is existence is the subject, but that's quite a question. So I understand that. And in this talk, though, she uses the term life, mind, and brain almost completely interchangeably. And this is a big part of the problem. And somebody actually, at the end, we're going to get to some of the audience questions that they asked her, because they were great questions, actually. And, I was even surprised at how good a lot of these questions were. But one of the questions was specifically that, was like, what's the difference between a brain and a mind, essentially? And, you throw in life into that mixture, and consciousness into that mixture, and these terms, what are they, really? And the issue is that these are super entangled. Their definitions would be super entangled, and that's why you can't solve one of them at a time, really. You have to kind of figure all of them out simultaneously, because they are defined by the relationships with each other. And, I say this a lot on here, is like, you are a brain, you are a mind, you have a brain. Okay. You are a mind, you have a brain. This means that there's a relationship there between these two terms. And in some way they are aiding in the contextualization of each other. And so that is, part of the issue with moving this discussion forward. And also you have people who prefer certain terms over other terms, like the term consciousness versus mind, or mind versus consciousness, or, life versus consciousness or mind, or sentience is the one that I like to use. And everybody has their own reasons for using them. I would hope that everybody has very specific reasons for using them. And that's kind of the point that I think some people are starting to make progress on understanding, but it is a critical component of this, and they get into that as well. And one of the people in the audience also brings up, the importance of asking the right questions and things like that, meaning having the right terms. And so this is all very intertwined or entangled, and you're not going to make much progress unless you kind of start from scratch. And I like that when she says that, instead of trying to define what, life or consciousness is, trying to instead look at what things do in order to define them, instead of what things are, quote unquote, meaning really what we call them now. And I think that that's a very big step, and it's an important thing. And when I was looking at sentient singularity theory, one of the things that is the big problem with this topic, when it comes to theories of everything, I guess you could say, or fundamental theories. I for my own piece of work, I prefer the term theory of every0ne, but it's very entangled. So let's open this. But one of the issues is mapping lineages of structure and defining that structure. So you'll see a lot when people first attempt this, and I've talked about this before, they'll go atom, molecule, cell, organism, and then, society or planet, and then solar system and galaxy, and then universe. And like, that's kind of the periodicity to this whole thing. And that I understand why they do that. I tried doing that as well. Sometimes they'll throw, crystal in there, or mineral in between molecule and cell, essentially. And the issue with this is that it's still relying on the context of space-time, which is not fundamental, and it's relying on the concept of size, which is not fundamental. And so this is a problem that has to be figured out, and assembly theory seems like it's attempting to do this. I have my own work that I've done on this, and we're going to talk about it tonight, but it's basically this right here, and you can see right here. So there's two sides to every single level or layer of sentience, I call this, which is the cosmological verse, or it's the periods of sentience, or the stages of sentience, I guess you could call it, within a cosmological verse. And what assembly theory seems to state is that this is kind of the levels of combinatorial time, I guess you could say, but we'll get into that more in a bit. But this, I believe, lines up with Bott periodicity. That is just a theory. I don't know if that is the case, and I hope to one day figure it out. But you have to figure out what are these levels of scaling that is absent size, I guess. It's not about size. It's about lineages and causation. And this is a lot about what assembly theory is about. So, we're going to get into it. But so she gets into what she calls the three hard problems that kind of are entangled, and that assembly theory, I think, attempts to reconcile. But here's this next clip.
So I think when we're looking at these hard problems, whether we're talking about consciousness, matter, or life, they have some common properties. So hard problem of consciousness, existing feels like something. Hard problem of matter is that we can't observe anything to exist outside of interactions with other objects. And the hard problem of life, the abstractions and information matter in determining what can exist or what happens. I think the last one is certainly true in the biosphere, right? Everything that has emerged in the biosphere over its 4 billion years of evolution is a product of some information that was selected over time. So all of these hard problems in some way deal with the nature of existence, and this to me is actually the most fundamental and interesting unifying thing about them, and also one of the ways that it kind of confronts the standard way we talk about things in physics and why there might be problems. So the nature of existence, what it is to exist, is consciousness. How do we determine what things exist is matter, and how some things can be caused to exist and others cannot, which is life. Emerge in the biosphere.
Okay, that's brilliant. So here, let me pull it up just again so I can see it. So the hard problems, she says, are the hard problem of consciousness, existing feels like something, at least for us. The hard problem of matter, nothing can be observed to exist outside of interactions. The hard problem of life, which is abstractions or information, is observed in matter and determines what can exist, essentially. So I guess what it is to exist is consciousness. How we determine things exist is matter, and how some things can be caused to exist and others cannot is life. I think that this is very close to how I would frame this, but I think I would change some definitions here or some words. So I wouldn't use the term consciousness just because I try and avoid the term consciousness. It's just it's too vague in a way, but it's not even vague. It has two different meanings. So if you're conscious, you're awake. If you're unconscious, you're asleep. But consciousness is something that isn't, it's like you are a consciousness, or what is consciousness for you? These are different ways of using the term. And I think that fact that we use it in two different ways makes it very messy. And so I use the term sentience, and so that we can say I'm unconscious or I'm conscious, and that, I guess, is dependent on perspective. When you're dreaming, you are conscious in your dream of your dream. You're just not conscious of the physical world that you, I guess, I don't even know if that's the right way to put it, because if you get into it deeply, what is physical is, how we determine things exist, which is matter. And so it's like what if we're inside a mind and all is mind, essentially, which I don't think that Sara Walker believes, but it is what my work suggests, then it is complicated on exactly what is matter. I think a better way of describing it would be what is perceived materially, I guess would be a better way of putting it than asking what is matter, and distinguishing things as material versus immaterial. It would be a much more matter of perspective. Matter is a matter of perspective, as I used to say more often, but I haven't said in a while. But it is true, according to my work, is that matter is a matter of perspective. If we're inside a mind and we're minds inside of a mind, then the thoughts of the mind that you're within would trump your thoughts, and therefore you would observe them as concrete reality. And so that's what I believe matter is. But I think these questions are good. And what she says, though, is that all of these questions, as is inevitable, is eventually they just deal with what is the nature of existence itself. But the thing is that the very first question is this hard problem of consciousness, which she states as what it is to exist. But then she'll state that consciousness is not fundamental later on when she was asked by, I believe, Stuart Hameroff. He was in the crowd and he got up and asked her a question. He said, I don't believe that you believe that that mind comes first. And I don't know exactly the technicalities of what that means, but if you just assume that means that sentience or mind is fundamental, then, and she said essentially that she didn't believe that it was. And so these questions, though, imply that it is, even within the questions, which it makes sense, actually, if it's true, and is that you wouldn't be able to get around this, really. And you can't. And that is the true thing that, I guess, that is the issue that people need to recognize in academia especially, but even, outside of it, is that you can't get around this question because it's woven into the nature of reality. And eventually you have to look at how deeply it's woven into that, into the nature of existence, to just, at some point you have to recognize that that's probably just the reality, is that sentience is the fundamental nature of existence. So you can't even write the hard problem of consciousness is what it is to exist, because exist in, people would say, oh yeah, in an internal sense, like what it feels like to exist. But then everything that we perceive is still to exist is still being perceived by us. So like there's no way around this. And but which I think is interesting, but it's still, I think that it's good that you take these three questions and then deal with kind of this fourth one, which is the summation of the three, and is kind of also a reflection of the first. And it's, you could say, these four fundamental questions. And what's interesting is that in my philosophical framework of sentient singularity theory, there's these four primary perspectives of inside, outside, separate, and oneness that are completely entangled. They're not really different questions, and or they're different perspectives, but they are not of a different perspectives of different things. They are different perspectives of one thing, I guess you could say. And it is how these entangled perspectives are co-defining of each other. That's what makes them entangled. Outside is separate from oneness, inside is separate and oneness. Oneness is outside and inside of separateness, essentially. It can also be even a bit more than that, and then separate is inside or outside of oneness. So it is how we orient outside of a relativistic framework. So outside of size and speed and strength and mass and all those kind of scales, I guess. And you'll see this pattern emerge in everything. So you'll see it in fundamental questions even. And so if we wanted to, we could do something where it's like outside, separate, and inside. And one of them would be, this would be what it is the nature of existence, then this one could be what is the, or you could just say the hard problem of matter. Maybe it could be there. And then this would be hard problem of consciousness. And then this one would be maybe how about this? Hard problem of life. Okay. And so these would correspond to these four primary perspectives. If these questions are indeed, fairly accurate, that's what I believe. And it does seem like they do. If you think about, what is the hard problem of consciousness deals with internal existence most fundamentally. What is the hard problem of life is these, it has to do with replicating distinct but also connected, chain of existing structures, I guess, and of growth. But it's like growth of beings. And then outside would be hard problem of matter, what is kind of separate from you. And then oneness is what is the nature of existence, which is basically all of these kind of combined. And they would line up with these definitions. And so that's what I think assembly theory is doing. And what's interesting also about assembly theory is when I first started my project, my philosophical investigation into the nature of sentience, many years ago, before I had a name for my theory, before I realized that was kind of an important thing, even I just called one of the structures in it, or kind of the model in its totality, I called it the United Quantum Force Assembly, or the United Conscious Force Assembly. And it was I called it both of those things at different times. And these terms are popping up in everybody's work, which is a good thing, actually, because it implies that we are converging on a truth, even if it's independent. And I think that's a good thing. Even if everybody's coming at it from a different perspective. You got Wolfram coming into it from kind of computer programming / mathematics perspective and physics, and then you've got Sara Walker and Lee Cronin coming at this from a chemical or chemistry and also physics and kind of, you could even say, astrobiology perspective. And then I came at this kind of from a just very first principles philosophical approach. And you're still ending up with the same kind of terms and problems and solutions even. So I think that the fact that those questions that she asked line up with my four primary perspectives are, kind of validating of those questions. But what is the nature of existence, I think, is a question that you have to ask and in a way that incorporates you into the question. And so what I have said before, and you can watch my Theories of Everything, the how-to guide video, which is also linked below, if you want an overview of this project and this the process and problems associated with a more fundamental theory than we currently have of all of these things, life, matter, consciousness. It would be a theory of all of them at once, because, like I said, these questions are completely entangled. They're all about the same thing. They are different perspectives of the same structure, which is, you could just call it existence, but or I would call it God. I don't know how comfortable these other people are at using that term, but I do remember that once Lex Fridman asked Lee Cronin and Sara Walker why God would create multiplicity of beingness, and I remember Sara Walker said something like, maybe because he was lonely. And I thought that was probably one of the most genuine and great answers to that question. I think that it's at least in part true, but whether she was being serious or not, it sounded like she was being serious, but I took it seriously. I thought it was a great answer. So here. So this is kind of an important thing to start thinking about, is information as well. So
information, I think, is a universal physics, but I think the place where it becomes most relevant is when we study life, because that's where that process is most concentrated. So we are the manifestation of whatever this physics is that we don't understand. Now, this is contrary in many ways to sort of the standard way we talk about things in physics. So I was taught in my physics class about particles in boxes, and also how brains can emerge from particles in boxes with very low probability. Has anybody heard this before, that we might be Boltzmann brains? Do you feel like a Boltzmann brain? I felt one like a minute ago, but I'm not sure now. No, yeah. Okay. So the argument is that brains can fluctuate into existence spontaneously because statistical physics allows it and quantum physics allows it. And I think there's a lot of problems with this argument for various reasons. One is that we've never observed it happen. So maybe you might want to ask questions about your laws of physics if they make predictions you can't observe. It is interesting in cases where people try to use this as cosmological bounds on like properties of the universe and stuff. So I think that they are interesting as a conceptual tool, but I don't think it's a physical argument. And it's interesting how the Boltzmann brain argument has permeated logic of other arguments that people want to make about the nature of life and mind and how they relate to physics. It's not like a culturally isolated phenomenon. It's like people really intrinsically think the universe can generate anything anywhere for free. And I think that's tantamount to intelligent design, because it basically says the universe has information for every object to spontaneously fluctuate into existence anywhere at any time. Where is all that information? Please tell me. Okay. People want to tell me in the audience I like this. Okay. Get some art.
okay, so I agree, with her statement of that a lot of this stuff is these like the idea of Boltzmann brains, if that's what it exactly means. I've forgotten the exact definition of it. I've looked it up in the past and have discussed it on my channel before, but it's been probably over a year. But the idea that a brain, quote unquote, not a mind necessarily, but a brain, we need to make sure that we understand that these are two not the same thing, and they can't be the same thing, because one of them is very obviously a physical organ, a physically perceived organ of the physically perceived body, which is a brain. And but the idea that with just it's very low probability, but given enough time or something like that, a brain or a mind would just spontaneously appear inside a box is kind of an insane idea, I think. I mean, it is an interesting philosophical, I guess, just tool, like she said, but it's not something that should be taken very seriously, because we've never observed it anywhere. And I agree with her, is that, if your ideas are not observed in your physics, then there's something missing. So, obviously it's true that brains and minds, I guess you could even say, but it's a tough question, a tough thing to get into, because you have to change the context of it all. I think that mind is fundamental, and that mind extends well below just even cells themselves. Even if you conceded that a cell was a mind, I think that there are minds in scales below cells. But she's right, though, that like it's not okay to just make the jump from, okay, well, brains exist, we see them in humans and dogs and I don't know, lizards or whatever, and so therefore the laws of physics allow for brains to manifest, and therefore you can just put a box somewhere, and given enough time, a brain will kind of emerge, because it's something that can happen, so eventually it will happen. And that's not really the right way to think about any of this. It's not about just there's so much missing, okay? So, and she gets into it later about like causality and how the future is, I think she said, and this is one of the best phrases I've ever heard, it is deterministic, but it is not determined. And that is very relevant to the idea of the evolution or construction of brains or minds, and it's not the same thing. I'm saying I'm applying it to both of those two concepts, and they do need to be handled differently. This is tough. I'm stumbling over my words because I'm thinking about how when I'm using some of these terms, it's outside the context of my own work, and I don't really agree with the context, and so I'm hesitating to use some of these words if it sounds like I'm just stuttering. I'm hesitant to use some of these terms the way that they are used in the contexts of these discussions. But still, I can't really help but engage in a kind of a common level playing field. And that presents difficulties because it means misusing some words, I think. But please comment any questions you have in the chat. What's up, memes? It really helps fuel the algorithm to also hit the like button. Subscribe if you're not already, and we will continue. But here, next question, or next clip. I think that this is just a continuation.
Got some arguments coming. I'm excited. All right. So where do brains come from? Well, if you deconstruct a brain and look at its past history, brains are products of evolution, right? So they have a long lineage. So this is a very abstract representation of a brain. It's a human brain, but just imagine, like it needs a body. So I'm not saying brains can be disembodied. So I'm just drawing a picture because I like drawing pictures. They're helpful. It's really hard to get the art right though. So minds don't spontaneously fluctuate into existence. They are assembled across time through evolution and selection. So if you think about every step to make a mind, to build a brain, every step takes time. And you can't compress all of that time into an instantaneous, spontaneous fluctuation. A mind is an object that requires time to be constructed. And evolution is a process we know that does that. And so part of the structure of the theory that we're building to explain life talks about objects as being assembled over time. There's a particular way we talk about assembly as a construction process. But the idea being that every evolved object has a structure across time as far as how it is built. So if you start from elementary building blocks, the way we think about it mostly is for molecules. Right now. So I'm doing a big reach right now by talking about brains, but it's supposed to be a general theory of evolution, and we're working our way toward universal features of the theory. And I have some promising stuff in both labs going on right now. Okay, so if you think about a mind, and you actually look at how you can construct the mind, that is the physical structure of the mind. This is gonna be the argument of my whole talk. It's not the instantaneous object of the brain, but the brain is an object that is very large in time. And I'm gonna say this over and over again, but this is sort of my conception of evolved objects. They're informational, and you can't see the informational properties because they are ones that have a size in time, not in space. Okay, so this is a mind. Now, I'll explain a little bit more in a few minutes about how we think about how to construct this kind of space. So I'm doing it very conceptually here in a quantitative framework, and as far as the theory that we're building and like the principles of the theory to kind of do like assembly theory 101. But one important feature of this is once you deconstruct an object in this way, you can see that it's been selected out of a very large space of possible objects, right? So if I took a brain apart, and I wanted to look at its pieces, the molecules that make it, those molecules could be assembled in an exponentially growing space. Every time I add two pieces of a molecule together, every time I form a bond, the size of the space gets exponentially larger. If I get to the size of cells, the space is even larger still. And once I get up to brains and technological civilizations, that space is very large. And it is so large, I don't even think that we can even imagine how big that space is. So remember I said,
so what's very interesting about this is some of the terms are really getting very, very similar. So if you look at my cosmological verse right here, and you'll see that basically if there are these periods or levels of sentience, essentially, and they're split into two different perspectives. One of them is a lineage-based perspective, and which moves across time. It's essentially assembly time or combinatorial time is what she and Lee Cronin call it. But I've just kind of called it like lineages maneuver within time is what I just say. I don't really have like a term for it that's distinct. And I don't think I should actually. I think maybe it's best to, unless you just called it lineage time. But there are these periods of assembly or growth, and where an organism is an assembly of cells, you can see. And a cell is an assembly of molecules, and an atom is an assembly of hadrons, and a hadron is an assembly of quarks. And so basically, there's always a little bit of overlap at some point, and it's not even just a little bit of overlap like in a general way. There's like a point of overlap, I guess is a better way of putting it, between hadrons and atoms. So for instance, a single proton would be also it is also a an atom. It's a hydrogen atom. So there's an overlap, a point of overlap between these two, and maybe that's there. I don't know. This is kind of there's a lot to still be learned about this that even I am still working on. But I do believe that this structure is kind of the outline of growth, of evolution, if you want to call it, and or of assembly, but assembly of sentience. And it's interesting that she ends with like all the way up to technological civilizations, and technology is an assembly of castes, which is a civilization. Essentially, it's a technological civilization is an assembly of castes. So we're really starting to use words that are very, very similar and getting to concepts that are very, very similar, and it does appear to be from independent work, which is great. And as I've said before on here, it's tempting to see other people start talking about the same things that you have been and describing similar structures and be kind of viewing it as a competition, but it should not be viewed that way. And the point is to get to the truth. And I do have those same I guess you could say egoic tendencies just like anybody else, but I have to step back and recognize that, no, this is a good thing. This is like validating of all this work that I've put in. And I also think that my work, as I showed, with the 4 primary perspectives and the questions that she's asking, I think that that's also validating of their work as well. So, that doesn't, I don't have a PhD, but that doesn't matter. The point is that, there's overlap to work that has been done and by, different people and different groups. So that's good. It's a good thing. But there's a lot of that. So if you look at, we're going to talk probably next week about Stephen Wolfram's observer theory, or we'll talk about Lee Cronin's with assembly theory. I'm not sure which one we'll do first. Probably Lee Cronin, actually. Then we'll talk about Wolfram and his observer theory that he recently named, I believe. And these are all very similar, and they're similar even to mine, and they're increasingly similar to mine. I'd say Wolfram's work now is closer to mine than it was even 3 years ago when I first saw his hypergraphs, and I was like, that kind of looks like just a different perspective on my my Excel models, and but then now it's like getting even closer, even though there's still differences. We'll talk about them, but assembly space is the same thing as the Reuliad in Wolfram's work. So it's the space of all possible rules, or the space of all possible assembly structures. It's the same exact thing. So eventually we're going to have to settle on one of these terms, and we should probably choose the one that is best at describing of what that's being mapped. So, but they're all getting close, so I don't know what's the best one, but I'm just saying we're going to have to get some common terms at some point. Speaking of,
brain apart. And I wanted to look at its pieces, the molecules that make it. Those molecules could be assembled in an exponentially growing space. Every time I add 2 pieces of a molecule together, every time I form a bond, the size of the space gets exponentially larger. If I get to the size of cells, the space is even larger still. And once I get up to brains and technological civilizations, that space is very large. And it is so large, I don't even think that we can even imagine how big that space is. So remember I said that we can't even estimate how many possible molecules there are with the known periodic table elements. So a brain actually is very deep as far as it's structured. But then as you're building up this space, you see what a huge space of possibilities that a mind exists in. And in some sense, the brain has carried with it that entire history. It's just rolled up in the present. So it has some capability of understanding the structure of the full space because it's a combinatorial space and it has some remnants of it stuck in the brain. When you look at that combinatorial space, there could be other minds in that space. And here I'm showing two kinds of brains that exist on our planet, which exist in the same combinatorial space and in fact share a lineage up to a certain point in their history before they diverge from each other. So if you look at the causal chains of events of operations or construction processes that assembled our brain, and you looked at the one that assembled an octopus brain, there would be a lot of overlap. We're not that dissimilar. But if I looked at my brain and somebody else's in the room, we're even more similar, which is one of the reasons we can share experiences with each other, is because we're practically the same object when you look at us deep in time. Now,
Okay, so when she's talking about these objects or these brains that share the same combinatorial space, what's interesting is she's using the octopus and the human, and so this is part of the problem is she's saying brain and she's showing a human brain, and then she's showing like it looks like neurons and molecules leading to cells, which lead to neurons, which lead to the brain, something like that. And then in the same combinatorial space, she shows an octopus, and she's saying these are two brains. They're not two brains. They are two beings that are minds, because mind is being. This is very, very important. And this has kind of been I think, if anything, is one of the strong points of my work, is because I started from scratch and I didn't come at this with all the academic baggage, I guess you could say, where I'm tied to certain pieces of work and a lot of training in specific, more narrow subjects, then I could really start from scratch in a way that most people would not if they are involved in academia. And it allows for you to really kind of not have to carry over misdefined terms, I guess. So I could start from scratch in how I use these terms a lot, and trying to also do it in a way that I could communicate to everybody, not just people with PhD, not just people who don't have a PhD, but everyone. And I can say, to you, you have a brain, you are a mind. And it should be pretty clear exactly, instantaneously what that means is, and it contextualizes both of them. So you're talking about minds, but the thing is what is a mind? If you start to deconstruct what is mind or what is a being, eventually you're going to probably have to concede that cells are beings and are minds, and that so are lower, even so are structures that occur in combinatorial spaces that are even below the cellular space. And so an octopus and a human being occur in the same combinatorial space that is basically, I believe, the same period in the periodicity of sentience. So that would be right here. This organism is an assembly of cells, this blue layer or wave, I guess, right here. An octopus and a human being would be in the same layer. Where would each of them be? I don't know. Probably human would be like there or something. It would be like very bleeding edge. But then an octopus would be somewhere else. And I don't know exactly. I can't tell you exactly the best way to break that up right now, but I'm sure that it will line up. Pretty sure. But this is one space. And then here you have the kind of the cells, the period that is the combinatorial space where cells are. And then here is the period that is the combinatorial space where molecules are, and so on and so forth. But like I said, these are two different perspectives on one thing. One of them is an assembly structure, molecules, an assembly of molecules. And then the other one is, a singular structure, which is, a cell. But it's very specific in that it is only dealing with structures that I believe are life, we could define it as, but they are sentient structures, is I think the best way to describe it. But if you really delve into the question of, what is life, then what you're going to get at is, you're going to start asking, is it alive? And what does it mean to be alive? Is it that it is sentient? If you were to die, right, and then we saw you, we would ask, is that alive? you would say, is he alive? But the he is gone if you're dead. So you're just a pile of cells that is an assembly structure, but it's not a unified assembly structure anymore, and that's the difference. And so that unified assembly structure is a sentient structure, and if it's not a unified assembly structure, then it's not a sentient structure. And so this is something that assembly theory has not gotten to yet. It will have to if it's going to go forward, and maybe it doesn't have to, and its value is in describing attributes of assembly structures regardless of whether or not they are sentient or not. But I think that you're going to run into some issues in quote-unquote combinatorial space, and in defining the different levels of the combinatorial space, as to try and use words that are assembly theory words in this talk, because that's what she is studying, but or working on assembling. They're assembling assembly theory, and so and it's an active process, and that's also true of my work. But there are certain things that I think are really even more they're not as figured out yet in assembly theory. There are some things that are more figured out in assembly theory than in my work, like a lot of mathematical equations and things that are relevant to this, I think. But they're the conceptual model or conceptual manifold structure of the big picture is not something that they have figured out as much as I have, I don't think. And that's it's more of a philosophical endeavor, and it also requires, like I said, kind of breaking free of some trapping ideas, like the idea that a brain and a mind are kind of interchangeable terms, and that's not true. So, or even an organism and a mind, even though that's more interchangeable, it's not all minds are multicellular organisms, even if all multicellular organisms are minds. Maybe that's not even true, or you need to change the terminology for that a bit. We can talk about that later, because I have a lot of ideas on it. But a lot of this problem is a lot of this task that is really the most critical is just figuring out the right words, which is funny because I've never been good with words, and if some of you might know from watching the stream long enough, but when I get it, though, I do get it. Just usually takes some time. So to continue.
Okay, so I mentioned at the beginning this assembly theory. So assembly theory is a theory that is structured to solve the problem of the origin of life, which I'll talk a little bit how we're thinking about that in a minute. But the way that it's like sort of the base of assembly theory is to say that there are objects you observe, right? Those objects we observe are physical things that exist, like you and me. And you can deconstruct those objects to their basic building blocks. So let's not talk about you and me because it's too complicated, but let's talk about a molecule. A molecule is made out of bonds. Right, so people think it's made out of atoms, but if you're actually talking about constructing a molecule is made out of bonds. So bonds are the physical thing that build molecules. Molecules made out of bonds. So if I take a molecule apart and I look at its bonds, there's a whole space of molecules I could build, that combinatorial space of chemistry I was talking about, and it's exponentially large. And in fact, if I had no physical constraints, that space is super exponentially growing with every new operation I do in that space. So that space is huge. That space is actually non-physical because I haven't imposed any of the laws of physics or operations we know that can happen in our real universe. So we might want to add some constraints and say we only want to do possible operations. We only want to make bonds that actually can form. So Lego is maybe even better. So some of you are not chemists. I see people scratching their heads, like thinking about how would you construct a human and how would you construct a molecule. How many people have played with Lego? Lego, okay, we know Lego. Okay, you know how they have little pieces on them? So like what are the knobs called? Studs. Let's just call them studs. Okay, so they have little studs on them, right? So assembly, the space of possible Lego structures, if there were no physics involved, no constraints imposed by how they have to fit together, let's say you have super glue, is like a really huge space, right? You can make all kinds of weird stuff out of Lego, and every time you add a new piece, the number of possibilities grows. If I am constraining myself to actually using those little studs to piece things together, I've constrained the space of possible objects to be ones that are physically consistent with the rules of the Lego universe. And then The next sort of constraint you might want to add is that you can't spontaneously assemble things for free. You have to build them out of things you built already. And this is what we call assembly clause or assembly contingent. This is an old label, so it's actually called assembly contingent in the paper, but that's this one. So we've added more constraints. And this is the feature that objects are built along historically contingent trajectories, which means if I want to build a Lego castle, I build a part of it first, and then I add that part to another part, and then I add that part to another part. And so this actually constrains the sort of trajectories through what objects get built, because once you start constraining and building things, you can only build out of what you built before. And so this means that the sort of trajectories for building objects are historically contingent. So what we see when we take objects that exist and we deconstruct them is a particular example of a contingent history, but it tells us something about the space of histories that could have been, that sort of space around it of what evolution could have done but didn't. And so assembly theory doesn't have initial conditions. It doesn't have laws of motion. It has objects and their causal histories and then constraining the future based on the causation that you find in objects in the present.
Okay. This is great. So much of this is great, and it's very. I think her use of Lego as an idea, as kind of like a model of what she means by that which of possible objects, plays a state of possible objects, I guess, is great. I mean, Lego was my favorite thing as a kid. So I think that most of us can relate to the, an understanding of what she's saying is that, like, if you just could super glue any blocks together and you didn't have to be constrained by using the studs and where you're building them on top of each other in the way that they're meant to connect, then you could just build anything. But the reality is that that's not actually how the universe works. It is, and she uses this term later on, this phrase later on, which is very good, which is that it is deterministic but not determined. And so same thing with Lego. There are possible moves that you can make, and there are moves that you could conceptualize but are not actually possible in the physical space. And so this is not something that we normally think about, even in enough. We don't think about it enough in physics, but it's starting to be more common. So they'd say, I guess if you think about like many worlds and stuff, you hear a lot of arguments that probably are not technical. They're just jargon spoken to the public that doesn't make any sense about how everything exists, and so you've got, universes in which there are different laws of physics and things like that. But I would say that doesn't really make sense. And that doesn't mean there aren't spaces with different rules, but there are certainly not different universes with different laws of physics, I think, than because you do have to start from an initial condition. And she said that assembly theory does not have an initial condition, and that's actually not true. It's impossible to have built for any of us to exist without a specific initial condition and an initial nature and structure of existence that is kind of what you build on. So when she says something like you can only build on that which already exists, it's very interesting. If you click on my Theories of Everything, the How-To Guide video of Every0ne. Let's just show this for real quick. This is very much similar things that I've been saying, and I'm not the first to have been saying this type of stuff, but it's just it's very important things and highly relevant things to do this. So here. What is fundamental? There is a common question that comes up in physics discussions, and that is, how do you get a universe from nothing? But not just any universe. A universe that contains the laws of nature that we can observe in our universe. Anything that is ever built is built on a foundation, and anything that is built out of something that already exists. If we want to try and build our universe, then we have to try and build one on foundational assumptions about fundamental existence. If we wanted to do so, there you go. It's funny because I use Lincoln logs in my Pace 1 video, which is linked below, which this clip came from. But it it's the same thing as Lego. Essentially it has constraints on how you put them together, and she's right though in saying that anything that is built on preceding structures or previously existing structures. You can't build something out of nothing, but that means that you can't say that assembly theory has no initial condition. You have to figure out what is that initial condition, and it's kind of inconsistent to say that assembly theory doesn't have an initial condition, but it recognizes that you can only build out of things that already exist. That's inconsistent. So there are things that there is an answer to that question, I think, but you have to, like I said, include yourself. Earlier I said this, but you have to include yourself in getting to the answer to that question of what is the initial condition, and you ask yourself, what is the truest thing that I know? And the answer to that is I am for everyone, which means that to exist is to be sentient, essentially, to be a someone, and from the deepest levels of our understanding of existence, that is what it means to exist. And we can't know from a third-person perspective whether or not someone exists within a structure, whether or not a structure is a sentient structure or not necessarily. I think that we can infer it, but I don't think you can know it. But you can infer it, and there's many ways in which that is usually possible, but some of those ways I think would be much more accurate than others. And then the next aspect of the initial condition, because you've got the what is the nature of existence? Someoneness, it's sentience. I know that that's not what she seems to believe at the end of this stream, but it is what seems to be supported by even her own questions about the four questions of being that she is asking towards the beginning of her lecture, which is one of them says, what is the hard problem of consciousness deals in what it means to exist. Okay. And then, the overarching question is, what is the nature of existence? It's like that she says later, it's like, well, maybe consciousness, to use a term I don't like, but sentience. You already defined it. Like those questions go in a loop, and they are entangled. They are in a knot, and you can't untangle them. You just have to map the connections. And so, what is the nature of existence is the question that she asked last. But the question that she asked first was, what is the hard problem of consciousness, essentially? And she defined it as dealing in what it means to exist. Okay, well, that's a full circle, guys. And this is what I mean by it's inescapable that this is the answer. Or it's inescapable, at least, that this is the answer that we must assume. And in a practical sense, like, that means that it is the answer that we must assume. We must go with, So I understand that you could say that what we must assume and what is true are two different things, but they're not from your perspective as an observer or as a maneuverer or as a mind who is trying to figure out the world. You can't disconnect those two things. What you have to assume is what you have to assume is true as well, and even if they do happen to be different, but you should assume that that's not the case, because if you're starting from actual proper foundations where it's really fundamental, then it should be you should be accurate. And if you're not starting from that which is truly fundamental, then you're increasing your probability of not being accurate. And the other aspect of this is, what is the structure of existence fundamentally, which that is oneness. And it's because existence is, by definition, all that exists, and therefore is one, And so it's when you're talking about assembly theory or the or constructor theory or sentient singularity theory or any other physics theory or metaphysics theory, whatever it may be, you're dealing in, eventually, how to map multiplicity and differentiation, and that, I mean, these are questions that are asked in this lecture by even the crowd, and attempted to be answered in this lecture by Sara Walker. And so I think that there's differences. There's two different structures. There's sentient structures and non-sentient structures, but and they differ a bit in how you have to approach them. But at the same time, there is an initial condition always of existence, and that is one of oneness and of sentience. It must be assumed. You could say, well, you don't know that, but it's like, you have to assume that. You have to assume that sentience is the fundamental nature of existence, because it is the one that you know to be true more than you know anything else. You have a first-person experienced perspective on the nature of existence, from inside the driver's seat. And you also have kind of the ability to abstract out and use logic to try and figure out what is the initial structure of existence. So I think that this initial condition that everybody talks about is like, what is the initial condition? It's not even it's not a bad question, but it doesn't give you any clues as to how to answer it. And what I have found is that due to the nature of existence itself, there are two different kind of aspects to the initial condition that are relevant. One of them is what is the nature of the initial condition of existence in its initial condition, and what is the structure of existence in its initial condition. And so you have to have kind of both of those, and they end up being super obvious, actually. And I mean super obvious in maybe kind of a technical way. It's like beyond obvious. It must be assumed by definition and by experience, and you can't just get rid of those things. You can try and argue around them, but good luck. I've tried, and I don't think that you will succeed. So this is just, it's a very interesting time right now in physics. If you are enjoying this, please hit the like button and comment any questions you have down below. But here, next clip. There were other things that I wanted to say, but I forgot them.
Now this gets at some interesting things, because what you talk about as fundamental in this theory is not what we talk about as fundamental in current theories of physics. And one of the reasons for that, I think, is really important, because, again, looking at the history of science, we have invented a lot of technology in the short history of science. And every time we invent new technologies, what we call fundamental changes. A good example is atoms, right? So atoms are the things in the periodic table, and they're called atoms because we thought they were indivisible, like the Greek atom. And then we realized they had substructure. And now sort of the most fundamental theories that people want to propose are things like string theory, which is even more fundamental, but currently inaccessible to our technology. We want to define fundamental as the smallest objects in the universe. The problem is, when you're an observer existing in the universe, what you call fundamental changes with your evolutionary history, how much technology you've evolved, how much you can measure. And so a theory of evolution that tells you about where you are in an evolutionary chain cannot have a fixed finite object as an indivisible object as your fundamental particle. It can't be the fundamental structure of your theory. So assembly theory is a theory of objects. It's kind of funny because I got through a whole physics education with every fundamental structure of your theory. How much technology you've evolved, how much you can measure. And so a theory of evolution that tells you about where you are in an evolutionary chain cannot have a fixed finite object as an indivisible object as your fundamental particle. It can't be the fundamental structure of your theory. So assembly theory is a theory of objects. It's kind of funny because I got through a whole physics education without knowing what an object was. And then I started thinking about it. And so we define objects as having several features. One is that they're finite and distinguishable. So you see a basketball and a soccer ball in the universe. You don't see a smear of every possible kind of configuration of ball in between. They're finite, distinguishable objects. Objects are breakable. I could decompose your brain into atoms. I can decompose a molecule into atoms. I cannot decompose an electron into anything. It is not an object. It's a limit of your observations.
Bingo. In so many ways, but in not completely. So for one thing, one of the things that I did touch on last a clip is that she said that molecules are made of bonds, not of atoms. She was like, most people think they're made of atoms, but they're actually made of bonds. That I think, I mean, I feel like you could go either way with that. I understand why you would say that, but let's see, molecules, atoms, bonds. Okay. The chemical bond is the association of atoms or ions to form molecules, crystals, and other structures. The bond may result from an electrostatic force. So yeah, I mean, I understand that, but I guess it just depends on what you mean by constructed of, and I think that it's a little different there, but still, regardless, I heard her say that, and I know that clashes with the model that I had put forward earlier, and I just wanted to touch on it. But the thing that I think is interesting here is she says that assembly theory is a theory of objects, and objects are finite and distinguishable. Objects are breakable. Objects exist more than once. Objects are lineages. Objects form via selection. Okay, so very interesting. But in sentient singularity theory, there are two, and this is being written into my paper, and it has been written into my paper already. This aspect of sentient singularity theory is that it divides the world into two different things, I guess you could say: sentient structures, aka beings, and non-sentient structures, aka things. Objects she seems to use to encompass both. And I don't know if that is something that you can continue to do and have it lead you down a path that makes sense, gives you serious progress. I think that you have to break it down. So when she says a brain can be decomposed into molecules, and a basketball can be decomposed into molecules, and they both can be cut up essentially. But the question is can you be cut up? This is a very key part of my work, and it is actually built into an experiment that I have been working on outlining that hopefully one day can be tested. And, I'll talk about more later this year. But once I start releasing more of the paper, but you can't be cut up into multiple parts. You disappear once we try and cut you up into multiple parts. So there are structures that are not able to be divided. They are finite and distinguishable, and also indivisible. And she says that you can't have it a theory that breaks down of life that kind of fundamentally breaks things down into indivisible singular structures, I guess you could say. And sentient singularity theory, my work with it takes a different approach. Is that there's two different ways of looking at it. There are assemblies that are lineages, and then there are singularities that are individuals. And so if you go to, let's just look here, this is my in a lot of this is just things that I've just been working on. This is not final models or anything like that, but this is just showing it right here. You have two different perspectives here. You have individuals, maneuvers in space, and this is what I think that lineage would look like. And then you have a lineage which maneuvers in time, or which would be like across spaces almost, or moments, and it would be these structures. And this is still of only sentient structures, and technology. People will be like, well, is technology sentient? I think eventually technology will be a united sentience, but the internet will wake up one day, or AGI will emerge. But that we have not reached that point yet. So no, I don't think that your laptop is sentient. But this has to do with unified feeling, I guess, is the way that these would be defined. So a completely entangled assembly structure is a sentient structure, and these are both two perspectives of sentient assembly structures. But they're also individuals. They exist in a superposition is what I'm getting at. So it's not that you can't fundamentally pick one or the other, really. I mean, once you get to the initial condition, the reality is that it is one indivisible sentient structure that is the initial condition of life and of existence, and there's no difference to that. Like I said, once we realize how we use the term alive to define life instead of these arbitrary definitions of it has metabolism and it replicates and it processes information or whatever, and it's made of cells. These are arbitrarily constraining, and there are actual I think the actual definition of something that would be alive, quote unquote, aka life, is because that which is alive is that which is life. That which is not alive is that which is not life, and that which is alive is that which is sentient. And we know that because when you are no longer sentient, you are no longer alive. And so therefore we kind of have these answers already, and it's built into our vocabulary and our linguistic frameworks for how we describe the world, but they have been also kind of ignored, and that is not the right way to go about this, I think. And you can see this even in or just maybe not ignored but overlooked, and you can see this even in where she gets into these 4 questions of life and consciousness and matter and also existence, kind of unifying all of them. And you can see that they're kind of self-defining in a way, is that she admits it in her definitions, even if if you asked her outside of that context, do you think that consciousness is fundamental, is the fundamental nature of existence, she'd probably say no. I don't know, but it seemed like she would say no based on her answer to Stuart Hameroff in the end. So this is all fundamental structures. My point is that they are all superposition structures, because they're all structures that have an internal state and an external structure, I guess. And so that's why I even said existence as the initial condition of existence, and also the inevitable condition of existence. They're one and the same. You have a superposition of 2 different perspectives that you must look at it as. One of them is what is the nature of it, and the other one is what is the structure of it. Sentience and oneness is the answer to those 2 questions, and that's the answer to the structure of life too. Is so you have a structure, and you have that is external, and you also have an internal nature, which is that of sentience. And so I think that that cells have this as well, and probably all cells, maybe not all cells, but probably all cells. And if not all cells, then there would be some cells that do not, and some cells that do have that are sentient, and some cells that are not. That would be corporisms, essentially. There'd be like a corporation is not sentient, and but that doesn't mean that a civilization can't be unified through a technological singularity of sentience that is stacked on top of the assembly. So you have this replication and stacking pattern that occurs, and if you look at my work here, Sentient Singularity .com, and you go here, and you go to writings, and you want to see the beginning of the paper, you go to technological description of existence, and see that describes the totality of existence as a singularity of sentience that is creating additional sentient singularities within itself. Sentience is the phenomenon of feelings, sensations, and emotions. Singularity is defined as something that is one distinct unit, which is exactly what she was just talking about, how you can't have it be formed on one distinct unit, but that's not exactly true. Or something that is especially unique. Sentient singularity theory also denotes a singularity as a structure that has the property of infinite oneness, aka maybe that's not the best term, but like a Mobius strip, or as one being that is composed of many beings, such as a multicellular organism. And sentient singularity theory can therefore be understood that everything that exists is part of a single universal sentient being that is producing an infinitely growing number of other sentient beings within itself. These additional singularities of sentience or self-aware beings are arranged into a nested quasi-periodic fractal pattern of stacked holonic structures within a single self-reflective knot of perception. And so it goes on, and these are these stacked structures are lineages, as what she is describing in assembly theory. But the problem is that it doesn't apply the same way to us as it does to basketballs. And that doesn't mean that there isn't a way to describe. There isn't a theory that can be used to map that space of perception, and maybe that is assembly theory. I'm hoping that's the case, because my theory isn't really focused on that. It admits that there is that exists, and then I kind of have focused on sentient structures and not non-sentient structures too much. Focused on the structures that sentient structures perceive of of the world, but not so much as the lineage of those structures construction. And I think that it's tough, because you could do it probably. I mean, that would be, hopefully assembly theory focuses on that. But they need to figure out that there's a difference. That's the thing, is like, you can't treat them the same way. But she says, objects are finite and distinguishable. According to who? Objects are breakable. Yes. According to who? Objects exist more than once. Okay. Sure. They're just there are things that we can define. All of this is about definitions. And so just to pull up my paper, I'll read some of it. It's very rough, but this is kind of important because it's relevant. So sentient beings that are perceiving of themselves. Okay, no, it says the interactions of two categories of supersubjective observations described above causes the emergence of the perception of space-time, as well as a dualistic view of the nature of existence. This emergent dualism of the nature of existence results in two categories listed below. One, sentient beings that are perceiving of themselves, and inanimate things which are perceived and defined by sentient beings. And so they are not self-perceiving, and they are perceived. And so a basketball is perceived, and a mind is self-perceiving and also perceiving of the basketball. And so the basketball doesn't perceive anything. And so where I specifically said inanimate things are perceived and defined by sentient beings. Okay, so when she's talking about objects being finite, distinguishable, objects are breakable, objects exist more than once, objects are lineages. I don't know about this one. This one is a little bit tough for me, to be quite honest. Doesn't fit within my the like definition of a lineage. And objects form via selection. Yes and no. That's a little bit more complicated. It depends on the metaphysical framework that you're placing all of this in. What is the definition of selection? But with a limit to the definition of selection is really what it matters. But objects are breakable, exist more than once, are finite and distinguishable. I don't know if those are all necessarily the best definitions, but some of them are. I mean, finite and distinguishable, are breakable, are I don't know about exist more than, or I guess I don't know about exist more than once. I don't know about that. What if there's only like one something ever made? You know, there's like one type of plane ever made or something. I mean, I don't know. It's tough. She might be right, because we couldn't define it if there's only one ever made, maybe. But and maybe that's also just because if there's only one ever made, we just haven't come up with a definition, so I can't even list it. But I think that it's important that we narrow down that there are two different objects. There are sentient objects, non-sentient objects, or sentient structures and non-sentient structures. And they have a specific causative relationship with each other. And there's a lot of context that's necessary to come to that conclusion, though, obviously. It's not just, I can't just say it and it fits into your work perfectly. But it might highlight that there are issues that, unsolved problems in assembly theory or whatever that might seem to align with what I'm stating about there's two different types of structures. And my work even implies that there would be two different types of structures, because there's always 2 degrees of freedom plus an intrinsic constraint plus an extrinsic constraint when it comes to us maneuvering or orienting. So within anything, any system. And so those 2 degrees of freedom, sentient and non-sentient structures. And even within that, you go down sentient structures, it's like, okay, there's lineages and there's individuals. And so you'll just see this pattern fractaling out every time you look, because it's coming from a mind. It's a reflection of the structure of mind. But a theory of objects, interesting. And they talk about complex objects. What is a complex object versus not? I think that you need to get into more like sentient structures versus non-sentient structures. And you'd get that. It'd be a better way of looking at things. So if you hear a baby crying, that's my daughter. My wife is with her. She's not being ignored. So next clip. I'm going to try and move quickly.
Of life. Can we find DNA? Is it a protein? How do I make amino acids from a prebiotic soup? That is not the question to ask. The question to ask is this system informational or not? Is it evidence that information was acquired over time? And how do we actually talk about that property? So we want to go after the actual physics, not the objects that we see. Like, what is the abstraction that explains them? So these are two of my favorite quotes on material reality. One from Roger Penrose, who we heard about this morning. I don't like the word materialist because it suggests we know what the material is. And Madonna knows she's a material girl, and we're living in a material world. Materials, coincidentally, are defined by our theories. And so I think I live in a material world, but I think the things that I think are material are more what other people call informational, because that's actually what we need to talk about when we talk about the physicality of objects like us, as I talked about. So this is kind of the image that emerges from these ideas about the nature of life. Life is about these lineages propagating information about these assembly spaces. Original life happens in chemistry. It's actually an abrupt transition. We have a really concrete way of talking about phase transitions in assembly spaces and when they happen, which will be a paper that I hope comes out later this year, which quantifies the original life in different spaces. New physics emerges in high-dimensional combinatorial spaces. What I mean by that is the physics of selection is only apparent when you have so many combinations, the universe cannot exhaust them all, so it has to choose. I say choose in an active sense because we do choosing, but not in a primordial soup. It doesn't choose, but selection does happen. So we can use mass spec to measure for molecules and validate that such a threshold exists. So this is a paper that came out in 2021 in Nature Communications, which took a whole bunch of samples of living, dead, samples blinded by NASA, put them through a mass spec, measured their assembly, and showed that biology was the only thing that produced molecules with high assembly. So we can use it for alien life detection, potentially. Paper that came out in 2021. We have a really concrete way of talking about phase transitions in assembly spaces and when they happen, which will be a paper that I hope comes out later this year, which quantifies the original life in different spaces. New physics emerges in high-dimensional combinatorial spaces. What I mean by that is the physics of selection is only...
I'm very interested. I have to read that paper. I would love to speak to Sara Walker or Every0ne at some point. It is a goal of mine, and to kind of go over this stuff, and I'd love to have them explain it in kind of a digestible way for people who aren't going to read the papers. But it's just, I'm hearing things like life in different combinatorial spaces, and it's like, well, okay, are we talking about cells versus multicellular organisms here? Are we talking about, like, are you assuming that molecules are life? And it's a bit complex because I don't know exactly what she's trying to say, but I mean, I would agree that, like, life is the process of a lineage of individuals that are of sentient structures that are evolving, maneuvering, and multiplying, and replicating and stacking is what I call it in sentient singularity theory. It's like when a bunch of cells replicate, and you've got all these cells in your body, and then there's also a singular being that is stacked on top of them, which is you, a human being, and so there's a singularity stacked on top of an assembly, and then there are structures where that doesn't happen, like a basketball. It might be an assembly structure of molecules, and there might be assembly structures of cells that exist. Maybe a lot of plants are this, where there is no singular being stacked on top of the assembly of beings, and so it would be not a there's no stacking that occurs in that of that assembly. And so there's a lot to this, and it's difficult, like I said, because contextualizing information, she talks about information a lot, and like I've said here before, is that fundamentally, sorry again for the crying, but it's, I have a newborn. She's adorable, by the way. We're going to do an entire stream about what I've learned from her developing and like learning the world. And I have like videos of her figuring out how to move her hands and stuff. It's fascinating. We're going to do a whole stream about it. But like I said, she's not being ignored. So no, don't get in the comments and call me a bad parent. But then I don't know. There's just a lot to this, because I said information. She's talking about information. Information is context. That's the definition of information. It is context. There's no information in context and outside of context. There's information is context. So next clip.
Produce molecules with high assembly. So we can use it for alien life detection, potentially. So we're at a conference about minds, not life. So I want to just talk a little bit about maybe some new philosophical structures emerging from this theory that I think are fun to play with when we're thinking about what a theory for minds might entail. The first is that minds do not exist as instantaneous objects. They exist within a historically contingent combinatorial space. Right? They are this sort of assembly. If assembly theory is on the right track in explaining the physics of life, and we can generalize to other kinds of physical things besides molecules, like the things molecules are built into, then minds should have a size and time just like molecules do. So I like this idea of thinking about hyperobjects, things that are too big for us to conceive. I think that we're not used to thinking about physical objects as having sizes and time. We see them as having size and space. When I look at a chair, I see the chair is a little more than a foot across. I don't see the feature that it took 1 billion years to construct the chair. But I also don't see that, that space-time is curved around me, right? So these abstractions we build from our theories are really non-intuitive, but the point is, are they explanatory or not? I think one of the things that this would explain, which I rather like, is the virtualization of reality. Because things that are informational, why do they look abstract? They look abstract because we're looking at objects that are really deep in time. They're really deeply recursively stacked objects. They compress a lot of time in a small volume of space. That's why they look virtual. And this means that other minds might be possible in the future of the construction process. So this brings the question of like technologies we're building now. Are they deeper in time than we are? Are they flat? I think the kind of technologies we have are more indicative of social minds than human minds, and therefore I don't really qualify them as creative as we are. But I'm happy to discuss all of those things. But I want to go back to
Dang. Okay. Actually, like I just realized something that I got wrong a bit, and I described it incorrectly earlier. When she's talking about a combinatorial space, she's not talking about this in my theory, which would be a period of sentience essentially. She's talking about this. Okay, it's this direction. It's the assembly of, you get to, a family, and then it's got like, it's built on this, organisms, which are built on these cells, which are built on these molecules, which are built on these hadrons, which are built on, these quarks in a way, but, but then that's a fundamental force point is what a quark really is. It's when she says an electron is it's a limit to our perception. That's correct. I call electrons in my work quarks are force points, and electrons are points of observation, essentially, or like I call them focus points. That's what I call them. I had a mind fart there for a second, mind blank, I guess. But I call them focus points. So it's a point of focus, which is the same thing as a point of observation, essentially. It's the limit to our observation. It's due to the constraints of focus and of our observation. So she's right. But same thing with quarks, but quarks are more than that. They're also force points that come from the universe, God. Whereas just electrons are not force points, they are focus points, and it's a little different. So, but you could say they are also focus points, quarks, but they're also force points, whereas an electron is not also a force point. But it's fascinating that this combinatorial space is like going perpendicular to my periodicity of sentience, which there's 4 stages of sentience, and then there's 8 periods in the periodicity of sentience, which I think is Bott periodicity, will align with the mathematical structure of Bott periodicity. But then combinatorial spaces are these kind of lineage spaces that go perpendicular to these spaces. Fascinating. That actually makes me. I like that it's something different, to what I'm doing. But also when she's talking about a theory of minds, a lot of this has to do with. I agree with her that there's minds that are deeper in time, and I have them listed. Technological sentience is what people call AGI. That is, I believe, a mind that is being built just by us naturally, and not something we have to try and build, but something that is being built. And but she says, that assembly theory is a theory of life, but then she uses the example of a chair versus a brain. It's just a bit, you can't treat these exactly the same way, but still, again, I think that this approach of assembly theory is fascinating, and the philosophical aspects of assembly theory are very relevant to a theory of creation. You can say evolution, but okay, well, if you're including a chair, then it's creation. It's the theory of creation, not just or a theory of selection, we could call it, and to kind of merge the two, which is, it's a theory of creation and evolution, which would be a theory of selection. And I actually like that term a lot. So, assembly theory would be a theory of selection. I think that makes a lot of sense. But one thing that I also wanted to mention is that when she says that a theory of life versus a theory of minds, again, it just shows that there's she's not viewing that as the same thing. And that is limiting, I think, because it's not correct. Minds and life are the same. And here's the other thing that I wanted to say that was very important is when she says, this is what I mean, framing is, context is information. That means that how you frame a question is essential to everything that comes from it. And so you can't get the right answer if you don't contextualize things properly, which means you don't ask the right question, or you don't contextualize the words of the question properly. So when you say things like that assembly theory has a lot to do with the origin of life, it's like, what is the definition of life? If it really means something sentient, then my theory would imply that there is no existence that is not where nothing was alive, because existence itself must be sentient by the nature of information itself. So if information is completely self-referencing, then that is what it means to be sentient. It's to be self-aware, which means it has to be completely entangled, which means completely self-referencing. And so that's an inevitability of the initial condition of existence, is that it's got information that is completely self-referencing. It is because all it has information about is itself, and that is something that continues always. Even while additional sentient singularities, sentient beings are created within it, it's still within this one being, and so therefore that sentience continues. It doesn't end at any point, because it can't. It's like a logical constraint. God can't kill himself even if he tried. He can't even try. I don't think. Not in any serious sense, because it's impossible for him to do it. So, she said in that interview with Lex Friedman years ago, that God maybe made more because he was lonely, and I thought that was a great answer. And it's like, it's also relevant to the question of causation, initial causation, but it's also important to, I think, just recognize that if you contextualize things that way, you can start asking other questions that are inevitably relevant, I think. So, like, God can't kill himself if he tried. It's like, okay, that means like sentience of existence is kind of fundamentally inescapable, and but that's just a way of saying it that that's easily understood by everybody. Okay. In my years and years ago, guys, just because I know that I say this a lot, I've been saying it, and people say that all the time, but just for instance, let's go way back to a video that I made in like 2019, but it was originally on a different channel, and here, let's see here. I think that this is
reject the default status, assume the opposite of what the default status is true, and test against it.
Such an easy code to write. That's one. Number two, you need the ability to imagine. Silicon does not have this. Okay? Okay, so I was talking about a technological sentience, and this was a very long time ago, and I said that there's 4 attributes that a technological sentience needs, and to its beingness in order to kind of exist. And this is true for all sentient structures. And one of those aspects is imagination. And I said this, and it's because it is built into kind of the structure of information processing, which is that you have to take the default status, assume the opposite of the default status is true, and test against it. In order to assume the opposite of the default status, you have to imagine the opposite of of your current default status, because you don't currently perceive it. You have to imagine it. So imagination is an essential component to minds. And she's right. And I think I've seen Carl Friston say this essentially too, and but I think that's it. And it's like her and Carl Friston and me, 5 years ago, and that's very cool. But here you go.
And to me, the most interesting thing that we do as humans is imagination. We can imagine things in our minds, we can share them between us, and then we can build them over centuries. And so an object that I like to use as an example is rockets, right? Humans were imagining sending things to space long before we had the theories or the technology to actually do it. But now.
So yeah, imagination. But I don't know if she would think that like cells have imagination, but I would say that they probably do. It's just much more limited than ours. And you know, I think that a technological sentient imagination would be less limited than, I don't even know if that's the right term, than ours, but it would be more capable. It would include more possibilities than ours does. Just like ours includes more possibilities than the imagination of a cell, which includes more possibilities than the imagination of a molecule, which includes more possibilities than the imagination of an atom. Well, I mean, some atoms are molecules. It's a little complicated there, but still, that's the point. And she's right. I thought that was brilliant. And this is the thing: is like when people say, "Oh, this is physics. This is math. This is it's neuroscience," and it's like, this is philosophy. Also, and you know, I said in my Theories of Everything, the how-to guide video, is what is a theory of everything? Is it a physics theory? No, it's not just a physics theory. It's a metaphysics theory, but that means that it is a theory of what is responsible for physics, which would be mind, and but it's also, that makes it a physics theory. That makes it a theory of biology. It makes it a theory of chemistry. It makes it a theory of technology. It makes it a theory of sociology. It makes it a theory of all of these things. And but it's fundamentally a theory of mind, because it's all these things are constructs. They are a construct that is a mind, or they are constructed by mind, or they are minds themselves, or they are defined by minds. And so it's all very relevant. And but yeah, imagination, key. She's brilliant, I will say. Like, one of the most brilliant, quote-unquote, physicists, and I say that not as an insult. Like, I mean, like, that I say that because I don't know what is physics and what is philosophy anymore, and I don't think that there's really that much of a differentiation when you're really doing it properly and you understand the context of what all is happening here. I think philosophy is... metaphysics is really, like, what it is. But it's also physics, and so, but you need to have the right perspective in order to like start making progress in physics, and I think that they are starting to have that. Not completely, but they're getting there. Major props, ASU. I know people rip on it. People talk about how ASU is like, it's like the joke of a universities. It's like, oh, where'd you go? ASU. It's like always in movies and stuff. That's the guy's the idiot, but you know, I grew up near the U of A, which is kind of a rival a little bit, and I went to NAU, which is another rival, but we're not on the same level in most ways. It was like the hippie mountain college of Flagstaff, Arizona. Those are the three major universities in Arizona, and ASU is the party school. U of A is like more serious sports, serious research, and then there's like the hippie school in the mountains. But you know, it seems like ASU is a very serious school when it comes to physics research right now, I will say.
Great talk, by the way. I'm going to keep it quick. You know, I often think about the way we actually perceive and go about solving issues through cognition and language. So your theory of mind is very interesting to me. And I'm wondering how much of getting the language right and the way you're actually describing things is going to affect the way you solve the problem. Because I know you talk about
I think absolutely
hyperobject.
100%. I use different words all the time and it confuses people, but it's because I don't want to become semantically closed. Because I think the words matter. I think they really matter. And I think when you're building a new abstraction, you're building a new language. And so you need to be really careful about what words you choose, for sure.
Obviously, as I've been saying, you know, been saying it. But he's right, and really good, you know, questions. Her answer is good. Like I said, though, you're gonna have to eventually constrain yourself, because you can't actually make any choices without constraints. You know, as she said, she says in this talk. The universe is deterministic. It is not the future is deterministic, but it is not determined. Okay, and the same thing goes with building anything, including assembly theory. So you have to constrain yourself in order to create paths that you can go down. And if there is no constraints placed, then there is no deterministic paths, and therefore there is no choices. And so it's eventually we're going to have to figure this out. It doesn't mean that you have to do it right now. You know, there are things that I'm not so sure of which term is best, but some of them I have. But with minds versus life versus, you know, minds versus brains, let's start there with assembly theory. If whoever works on assembly theory ever watches this, like, I understand it's a jump to get to where some of the things that I'm talking about with sentient existence and that being fundamental, but let's just start with defining those structures that are minds, those structures that are not minds, and also differentiating between mind and a brain. A brain is, you have a brain, you are a mind. And so a basketball is not a mind, but you are a mind. A fish is a mind. A cell is a mind. And then I would argue also like structures below. But I think that that's a pretty easy place to start, but like we have to constrain ourselves a little bit. And then this person asked a very good question.
Since you use the word object a lot,
Yeah.
where
It's
does
a new one for me. I like it.
where does an object end?
Oh, where does it end?
What's boundary in space or space-time?
Yeah, I think the idea that they have to have finite boundaries. So for molecules, it's actually pretty easy to define the boundary because of like the sort of, you know, like molecules are like have an energy potential and things that actually give them physical structure. One of the reasons we're having a hard time developing assembly theory for minerals is because it's really hard to define what an object is in a mineral. There's like a crystal unit cell, but the way it repeats is not exact copies because of defects. So it's super hard to define an object in a mineral. And it's also hard to define objects in some classes of strings, although in other classes of strings it gets a little easier because there's like some semantics about what bounds a string. But there's a couple things that are really hard about assembly theory. One is defining, like constructing the mathematics of it for new spaces. One is, what is an object? And two is, what are the physical mechanisms of constructing the object? And if you know those two things, you can construct an assembly theory for anything. But those things are actually super hard to define in a way that's rigorous and measurable. And this is one of the reasons that we're taking our time trying to develop assembly theory properly for other kinds of systems besides molecules. Molecules were like a freebie. They have these properties.
So this is fascinating. I wonder if this is because these molecules were freebie because they are at a level that is still sentient, maybe. I don't know. My framework is broad enough to where it seems to imply that, but I also haven't delved that deeply into like certain molecules would be sentient, certain molecules would not. I don't know. But it might be that all molecules are essentially sentient. Maybe that's not true though, but in which case then you have to break down which ones are sentient, which ones are not. But this problem that she described here is exactly what I'm talking about. When I was mentioning this at the beginning of the stream, is that you see when everybody goes down this path, they're like, okay, there's atoms and there's molecules and there's cells, and then they're like minerals, which is crystals, and then that kind of goes off from there. That is a mistake, I think. Now, maybe assembly theory is not meant to do what my work is meant to do, and it's just meant to focus on non-sentient structures. But you have to realize that there's a difference between the two, and then you have to focus on one of them. And it also has to be contextualized within the context of sentient structures, because sentient structures are responsible for defining and perceiving the bounds and limits to non-sentient structures. Where does a basketball end, and the room that the basketball is within begin, and or where's the boundaries between these things? What's the boundaries between this basketball and that basketball is dependent upon my definition and perception as a sentient being. So you have to contextualize the assembly theory of non-sentient structures within the theory of sentient singularities. And I'm not just saying that because, oh, wow, of course you'd say that. No, it's deeper than that. It's like, of course that would be the case. It's not, of course, I would say it. It's like, of course, that would be the case. And so it's still fascinating that they're dealing with this problem. And the fact that they run into it with minerals and or crystals is just funny, because that is like, it is where everybody gets lost that I've seen in this, or at least most people. And I remember myself even trying to figure out how to get past this, and I had an epiphany about it, and I realized, like, no, that is not the right way to go. But I understand why it's so easy to get lost, because you've got this replicating structure, and but that doesn't. It's not singularity. It's just a structure that multiple examples exist of, just like basketballs. And so they're constructed and perceived and defined by sentient beings, crystals, but they're not sentient themselves. And that's fascinating. I mean, we make crystal structures like basketballs. There's a little variation, but like for the most part, they have this like, common pattern. And if you didn't know that we were sentient and you just saw basketballs appearing, like, you'd be like, wow, that's a basketball crystal, and but I don't think that crystal structures can be, like minerals, can be thought of the same way as molecules. At least not all molecules. Again, there's sentient structures and non-sentient structures. We got to figure this out.
One off the bat. It's really weird. Yeah.
Isha? Oh, sorry, I just have one question. If
So funny that it's the exact same thing. Again, she's talking here bundles of lineages.
Things that are no longer part of it. So,
Yeah.
for an example, is a human mind part of the object because it's part of the history that created it, of a rocket?
Yeah, it's super interesting. Like I have to kind of compress things to like be able to explain them. But this idea of lineages of propagating information is really something that we've been developing with Michael Lockman at Santa Fe Institute. And Michael, has this really nice way of talking about it, which I really resonate with. Is like, we are bundles of lineages. So you're not like you're a particular configuration that has come together, but your parts, like all the things you create or all the things that are parts of you, can also become parts of other objects. So you're not like, so the example I like to give is like Einstein's biological lineage wasn't very creative in the universe. He doesn't have a lot of ancestors, right? But his creative lineage, like the ideas he created, have propagated through a lot of minds. So that lineage has actually been much more persistent than his biological lineage. But they're both lineages, and they both should be talked about as objects equivalent assembly theory. It doesn't make a distinction between abstract objects and things that we would traditionally consider physical objects.
Thank you for the speech. My question is, when you're talking about mind, you use brain as an illustration.
Yes.
Was I not? Was I? Man, great. Was I On mute? Okay, well, my point is that what she said in the previous clip, in the case that if I was muted, is that she has divided this into into physical structures and non-physical structures, and that when she's talking about Einstein's ideas versus his children, that's not the right way to divide it. It's his children would be sentient structures, and his ideas and all the atom bombs and institutions and theories that emerged from his ideas would be non-sentient structures that would emerge or be caused by him as a sentient being. And she said that assembly theory does not distinguish between these two. She says physical structures and non-physical structures, but I'm saying it's sentient structures and non-sentient structures, and that there might be some relevance to not distinguishing between those two, but I think that doing so would be limiting to your ability to describe and explain those structures. So she's miscontextualizing, I think. It's not non-physical versus physical. She's talking about like physical just meaning informational earlier. This is not consistent with what she said earlier. She says that physicality, matter is just information, and that I agree with her actually, her previous statement. And if that's the case, then like you can't divide this between physical, aka material structures, and non-physical structures. That's not even. And she says that they don't make a differentiation, but like there is a difference in causative ability, and degrees of freedom that are able to be expressed by each of those structures. One of them has the ability to make choices, the other one does not. His ideas do not make choices. His offspring would be able to make choices, and so you have to kind of differentiate them eventually. And also, like, who's defining his ideas? Sentient structures, like offspring of people. So like they don't exist outside of that. That's different from his offspring, which might exist outside of him, his ideas, or that people would exist outside of Einstein's ideas, but Einstein's ideas don't exist outside of people. There's a directionality of causation between these two different structures, sentient structures versus non-sentient structures.
Isolated from the rest neural system. So
I wanted to put a nervous system. I just couldn't get a good visual. So I use my So this is one of the things about the semantics. Like, which word do I use? Brain, mind, nervous system. Like, what do I actually mean? I don't know.
Okay, perfect. So
I'm agnostic.
Next question. The question is related.
Yeah.
What about conjoined twins like that?
So again, this is exactly what I was saying earlier. She's using minds, brains interchangeably, and life even sometimes interchangeably. They're not interchangeable. I think minds and life would be interchangeable, but not actually brains and minds, or brains and life. You are a mind, you have a brain, again. But the fact that it's coming up, been saying it. And this was Stuart Hammeroff's question to her.
Great. I take it you're going to disagree with my contention that consciousness came first.
Yes.
My question is, what's the role? Does life? I also believe that life, even very simple life, requires quantum coherence at the micelle level, the cellular level, and so forth. Do you disagree with that also?
My philosophy on quantum physics and its role in life is kind of similar to my philosophy on thermodynamics and also gravity. I think these are theories that describe features of physical reality, but I don't think they're capturing the regularities relevant to what life is doing. So things that life builds will have those properties because life is a physical system. But the abstraction we want to call life, is not embedded in those theories.
Why is it an abstraction? But I'll just leave it at that.
Well, because theories are abstractions.
But life isn't a life.
Okay. I will say this. I disagree with her that if she means like consciousness is not fundamental, then I would disagree with that. Or sentience is, but I will say that I do agree with her about what she said, that basically that what life is doing, or what life is that it is going to require more than our current physics and theories to explain. Basically, it's beyond just quantum physics. It might be observed within our physical theories and biological theories and chemical theories, etc. But it's not actually occurring within those frameworks. And so quantum physics is not what is responsible for sentience. Sentience is responsible for the observation of quantum physics. And that, I don't know if she would agree with that exact description, but that is something that I will say. But very much similar. I think this was the final clip.
What fundamental principles do you have in assembly theory that distinguish conscious from non-conscious entities?
It's interesting because people always want. I made a joke a few minutes ago, but I'm like way more interested in what's happening in the unconscious than my consciousness, because all these things just like pop in the surface sometimes, and I'm like, where did that come from? And so I think it's interesting that we have experience in things, but I'm not sure it's the most interesting thing going on in our brains. But that being said, I think the main difference is, in the only way I know how to like codify in English language, is this idea of imagination. I think for most of biological history, objects were built on things that, sort of existed in this like very like much smaller combinatorial space, because the objects don't have as large a history. And there's something about the structure of the brain that I think the history is actually larger than like the space. So it actually seems like it's pulling counterfactuals into existence, but it's because it exists in a larger space than is like, I don't know how to articulate it yet. But that's the closest answer I can give. Trying to work toward actually like formalizing that, but it's really hard.
Major props to her for that last final bit, where she says that imagination is one of those things that she thinks would be distinguishing between conscious versus non-conscious entities. And I don't even like the term conscious versus non-conscious entities, because an entity is usually assumed to be conscious. But again, sentient structures versus non-sentient structures is how I would describe it. And this exact question is the perfect one to end on, because it is exactly what I've been saying is kind of the issue with assembly theory and constructor theory as well, and probably also maybe observer theory. I don't know. In some ways, there seems to be an issue, but we'll get into that when I talk about Wolfram's stream with Curt. But this is the perfect question to end on, because it is exactly what I've been saying, is like, this is limiting of assembly theory or any theory that is about trying to map fundamental reality, is not differentiating between sentient and non-sentient structures. And she admits it's very hard, and I think that it is difficult until you do it, and then once you do it, it seems like it was obvious. And it's like super obvious, though. It's like fish looking for water, and of course that would be the case, but I understand why it is kind of so difficult, especially when you're starting from the standpoint of being within academia and having a bunch of preconceptions that are really fundamental to how you approach problems, or really built into how you approach problems and how you linguistically contextualize questions and problems. And so but I think it is a great question, and I think that it needs an answer. But I think that one of those answers would be imagination. And but yeah, so with that, thank you, everybody. Please hit the like button, share this. If you want to watch our full talk, it is listed below in the description. And with that,